Good morning, everyone. I hope you're having a great day. Today, we're going to be talking about present and accumulated value of an annuity. What present value is going to do is basically it's going to tell us the current cost of the annuity that you're buying. Okay, so today we'll only be working with annuity immediates, and the annuity immediates are the ones where you're going to have level payments over a period of time, and the payments are going to start at the end of the end of the first period. We only have time for this today, otherwise I could get into a lot more detail. But there are two ways to solve it. We can either use the keys on our calculator, TVM keys, these white ones right here, or we can solve it algebraically. But today we're just going to do it on the calculator, and I'll just have you do it algebraically on this side. Now we're going to go over into what the equation for present value is going to look like. So what we have, we're going to say PV for short, and we have 1 minus V to the n all over I. Now this V to the n here really just stands for 1 over 1 plus I to the n, so it's pretty simple. And then the I is always going to be interest, and that's here too. And then we have this n is going to stand for the number of periods. This isn't very hard, but there's an easier way using actuarial notation. So the actuarial notation for present value is going to be A angle n at rate I, right here, just like that. And the n, again, is going to stand for the number of periods, and the I is going to stand for interest. What actuarial notation does is it makes it easier for us to understand where the numbers come from and everything. So if I were to write 100 A angle 3 at, let's say, 5%, this means that our payments are 100, 3 is the number of periods we have, and then we have 5% as our interest rate. And using this, we're able to plug all these numbers into our TVM keys on our calculator. Now on our calculator, you're always going to want to press second F value because that's going to clear all the values out of your keys. So, for example, for this example right here, we're going to have 100, and we're going to set that equal to payment right here. And then that's all done. And then our periods were 3, so you're going to put 3, and that's going to go for N. And then our interest rate was 5%, so we always put it as a percent. So we just put 5, and then that's going to be the I over Y. And then all you're going to do is press CPT up here at the top and PV. And then our present value ends up being 272, and you always just ignore the negative sign. Now, I just worked this out algebraically, just on my own off to the side. And as you can see, you end up getting the exact same answer. Okay, now we're going to move forward into accumulated value rather than present value. Accumulated value is going to basically just be how much the annuity is worth in the future at the time of the last payment. Okay, so now for accumulated value, our equation is going to be 1 plus I to the n minus 1 all over I. And again, the n is the number of periods and the I is the interest rate. The actuarial notation for this one is going to be S angle n at rate I. So the exact same thing if I were to write 100 S angle 3 at 5%. This is going to stand for the number of payments, this the number of periods, and this is the interest rate. Okay, now entering this on the calculator is going to be very similar to how we did present value. So you're going to press clear TVM. Since the payment is 100, you're going to do 100 equals payment. The periods is 3 equals n, and 5% is I over Y. And then this time you're just going to press compute FV and ignore the negative sign. And I just worked it out algebraically again here, and I get the exact same answer. Alright, now there's a lot more things that you can do with present and accumulated value, but we'll get to that in future lessons. And make sure you have these two equations written down because you're going to have to memorize them. And I hope you all do very well during finals week and have a great break.